Hello there, today we'll be doing number 46, invert binary tree. This should be an easy problem, but if you're, this is the first time you're seeing trees, it's going to be pretty difficult. So in trees, there are some things that you should see to remember. There is the pre-order, in-order, and post-order traversal. These traversals allow us to traverse through every single node of the tree. Pre-order means that before we make an, we're gonna basically, I think, make an operation and then go left, then go right. In order traversal is that we go left, then we make the operation, then we go right. And post-order traversal is you go left, then you go right, then you make the operation. So this is, so here's what I mean, the operation. Let's suppose we get ourselves in this particular item where we have these, this particular tree here. So what operation that we can take here is that what we're gonna do is, let's say we add a single 1 to 4 first, and then we go left, then we add a single 1 to 2, then we go left, then we add a single 1 to 1, then go left. Of course there's nothing there, and that's the base case with these traversals. And then you go right, then you go back up, and you go back up to your previous node because you're complete. So these are depth first search traversals. That means we're going to go as deep as possible before we traverse back up. So now we traverse to the right because this operation has been done, and we're going to add 1, and then we're going to go left and then go right and go back up to our top node because we still haven't gone right yet. Then we do the right. Then we have 8. Then we go left. We have 7, and then we go right. We have 10 here. So with this operation, you can see that we go this way first. So then in order operation is when we're gonna go left first, then go left, then go left until there's nothing left. Go left again, go back up. When we return to our node, that's when we make the operation, and then we go right. So then when we return to this node, we make an operation, we go right, and we go left, go right. So we go left here, we go right, and then we do the operation, and we return to this spot, then we do the operation, as you can see. Then we go right, then we go left, right, make the operation, then go back here, make the operation, and then make this as our last operation. And lastly, we're going to go left all the way down, left, right, then make an operation, go back up, go right, make an operation, because we go left and we go right, then we make an operation. Then this means we make an operation at this time. Once we return after we complete this bottom row, we make an operation. We still don't make an operation here yet because we have not completed our operations down here. So we go right, go left, left, right, then we make an operation, go back up. We're not done yet with this operation. We need to complete this one. So we go down here, left, right, make an operation, go back up. Now this is going to be 10, and once this operation is complete, then we can make an operation for this one. This is going to be our last item to have an operation in a post-order traversal. So one of these operations will work for us, and I believe that is post-order traversal, because we want to do is we're going to make some swaps between the bottoms before we make a swap here at this layer, because we want to swap these before we swap these up here. So let me show you what I mean. So we're going to try this with the 3 different types of traversals and see what happens. I'm sure this is much more beginner video than you expected maybe, but I think it's going to be a good refresher. So let's see what happens. So let's say we did a pre-order. We made an operation here. Let's swap here. So we're going to swap our left and right. So what's going to happen next is we're going to have a 7 with a 6 and a 9 attached. And we're going to swap 2 and 1, 3. We're swapping the entire node. The node has nodes attached to it, left and right. So that's the first swap. So we made an operation. Then we go left here, and then left here we make an operation. So these swap. And now we go down here, we make an operation, we swap these. There's nothing here to swap. We go back up, and then we go back up again. Of course, we went left, now we have to go right. We make an operation. There's nothing to be operated on, and then we go back up, go right, because there's no, that's what we need to do. Make an operation, 3, 1. And now we go left, go right, go left, go right. There's nothing to do here. And I think we have a solution here. Let's try it. And see what happens with pre-order traversal. So how do we do this? What you need is a DFS call, self, and we need a, let's say, a root node. So this root node is what we're gonna do is we're gonna make if not root. We're gonna return, and otherwise we're gonna make an operation first. The operation is root dot left and root dot right. We're gonna swap these two. So what's going to happen is root dot left is going to be equal to root dot right, and root dot right is going to be root dot left. Usually in regular languages, we can't do this operation. We have to take separate steps and make a temporary variable to hold our point before we swap. Now that we're done swapping, we're going to run DFS on root dot left and DFS on root dot right. So this satisfies our pre-order traversal. With that, we are complete with this operation. Let's run it. So self.dfs root return root. Let's check it out. Looks like it was successful. All right, it looks like it went very well. All right, let's try in order traversal. In order traversal, what's going to happen is we go left, then we go left again, and we make our operation, and then we go back up, and then we go right and make an operation. So now we go back here to 2. At this point, we make an operation. So we're going to swap these nodes. So let's copy and paste. So we make a swap here, 3 and 1. Then we go right, and we make a left middle operation, right, do nothing. Go back up. Make an operation. So what's going to happen here? This operation is going to swap these two. So we're going to have a 7, 6, 9 over here. And we're going to have 2, 3, 1 here. Then, at this point, what's going to happen is that after the swap, we're going to be swapping, we're going to be going left, because currently we're still here. I mean, yeah, we made the operation be over here. So now we're here at the spot, and we're going to go, well, left, and then right, and then we're going to make an operation. We're going to have a 1 here, and we're going to have a 3 here after this operation, and we're going to go down this way, and once we go back up, we make no changes. So in order traversal should not work. Let's check that out. As you can see, it is incorrect, and we have a 4, a 7, and a 2. So this is exactly what I have here. Then we have a 6, 9, and a 1, 3, which is exactly what I have here. And that is not what we want, because what we actually want is that we swap these 6 and 9s around, and not these 1 and 3s again. Now let's do this one more time with post-order traversal. Let's check this out. So in post-order traversal, it should be fine as well. So what's going to happen is we're going to make an operation after the fact. So we're going to go all the way down, left, left, right. Then we go back up, make an operation, nothing to operate on. Go back up, go right, left, right, nothing to operate on. 3. So make that operation, swap the 2. So we have this picture here. We go back up to 2. Then we're still not making an operation. I guess that's when we make an operation and swap the 2. And we go back up. We don't make an operation yet. We go right. We don't make an operation on any of these. We go left. We go right. Make an operation on 6. There's nothing to operate on. Go back to 7. Go back to 9. Go right. All right. Try to make operation. Nothing to operate on. Go back up. Then we make an operation change. We have a 9 and 6 here. And once we return to 4, we make that last operation, and we swap the 7 and the 2 with all of its respective items intact, 3 and 1. And this is where we see the temporary variable needed to store it while we move it into place. Of course, in Python, we don't need to do that. But I will show you how that's done as well. Let me just give me a moment, and we will see that shortly. So after we run this code, as you can see, post-order notation also works. I mean, post-order traversal. And so, so the temporary variable. So what I'm saying is, we'll create a temporary node equals root.left. So root.right is going to be equal to, root.left. So we're keeping the left side temporary, and what that means is that we can basically change left now to be right, and root.right can become the temp node. And with that, we have swapped, created a swap as well, how we generally would swap it. So run the code. As you can see, it works perfectly fine. This is essentially what this line does, essentially. And we can also run this operation here on the pre-order as well. And with that, I think we have gone over invert tree in 2 separate ways and one way that does not work. And we looked at it and figured out why. So we also went over how to write out this notation here, what this does exactly. Well, what this does exactly is that it swaps it immediately before anything changes, so everything's saved in memory. Both of these are saved in memory, and we sent at the same time, and we just moved the two items. With this, because these are separate operations, we had to store one before we moved it. Anyways, with that, we have completed this problem. I hope you enjoyed this video. If you did, please like and subscribe. Want more video? Check the link in the description below, and I will see you in the next one. Bye.